Hello. Today I will teach you about threads. I know that you're thinking that it's not you put in the needle. Not that thread, okay? The thread that I'm mentioning is the fundamental elements of the central processing unit known as CPU. That is the core component of a system unit. A traditional process has a single thread of control, but it depends if a process has a multiple threads and it can perform more one task at a time. But you always remember that every CPU has a threads. There's a multi-thread and there's a single thread. And the thread that we're gonna discuss today, it contains the following attributes: thread execution state, a saved thread context when not running, some per thread static storage for local variables, access to the memory and resource of the process, and lastly, an execution task stack. That is the attributes that contain a thread. And another thing, there are few lists of attributes that we discussed previously that there's a characterize a Windows thread object. And the first one is the thread ID. So, what is the thread ID? A unique value that identifies a thread. And thread context. So, the thread context is it focuses on the set of the register's values and other volatile data that defines the execution state of a thread. And another is dynamic priority. It contains the thread's execution priority at any given moment. And thread exit status, the reason for thread's termination. And are the few of it. And there are many more. Each process is represented by an object that includes specific attributes and encapsulates a number of actions or services. You can see the other attributes if you search them in the Windows Threads object in the Google. And we know that threads has their own arrangement. Did you know that they have their own arrangement that you call the process and thread arrangement? And you can call the relationships may occur. So the arrangement is the first thing is the one process and one thread. So it means that each thread of execution, this contains a thread of execution has their own unique process that you call with its own address space and resources. That is the meaning of the one process and one thread. They have the uniqueness of each process because they have their own address space and resources. The next one is the multiple processes and one thread per process. So this contains a thread that may migrate from one process environment to another. It's specified for it that it can allow thread to be easy move among distinct systems. It depends what kind of distinct systems it is. And another thing is the one process multiple threads. So this defines a specific address space and a dynamic. And the lastly is the multiple process and multiple threads per processes. So this has the combined attributes of the M1 and the 1M arrangement. So it means that it combines the multiple process one thread process and the one process multiple threads. And lastly is the thread state. So in the thread state, that means that the key states for a thread, the key states of the thread is the three of it is running, ready, and block. So the example it is, so if a process is swapped out, noted that all its threads are automatically swapped out because they all share the address space of the process. That is the meaning of the thread state. And there are the following four basic thread operations to change the thread state. Did you know that? So I will break it down to you that there are four. So it is number one, spawn. So the spawn it contains the operation typically transpires whenever a new process is created. So since the thread for the specific process is also formed too when the spawn, that operation of the spawn. And the second one is block. So this operation happens when the thread needs to wait for a particular event. So all the necessary informations are automatically saved for the thread execution resumption. So the third one is unblock. So the operation of the unblock is to move the block thread into the ready queue for the it's a continuation of its execution. So if a block thread is still waiting for it, the unblock operation, may is gonna move it into the ready queue. And the last is the finish. So it will happen whenever a thread completes its entire execution. And its registers too. The settings in the stack are deallocated. As you see below the illustration of the windows when the thread state used in the windows, as you see there, you can identify how it performs or process it in when a thread. And the next thing is the thread synchronization. So what is synchronization of the thread? So the all the threads has the process to share the same address and space and address space and resources. And any alteration of the resources by one thread affects the environment of the other threads within the same process. So that means that it's synchronized and same the address space and resources of the threads. That's the meaning of the thread synchronization. And the other one is the thread library. So what is that? So the thread library, it contains any application can be programmed to be multi-threaded with the use of the thread library. So the thread libraries is for the multi-threaded for the multi-threaded. So it provides the programmer with an application programming interface. It's called the API for creating and managing threads. So that is the meaning of the thread library. And did you know that there's a types of threads? The first one is the user level threads. So the user level threads, all the threads are management is done by the application. And the system kernel is not aware of the existence of the threads and continues to schedule the process as a unit. And I will show you some advantages of the implementation of the user level threads. So the advantages of that is the thread can switch. The thread switching does not require kernel mode privileges since the overall thread data management structure is within the user address space of a single process. And when you scheduling can be application specific. The scheduling can be application specific. And the lastly is you can run it on any operating system. It's very flexible. There are no changes required to the underlying kernel in order to support user level threads. What is multi-threading? As you can see in many operating system, it's important to have a multi-thread processor. So multi-threading pertains to ability of an operating system or OS, as you call, to support multiple or concurrent paths of execution within a single process. So they use it of the multi-core systems to provision applications with the multiple thread effects, the application design and performance. So I will show you I will discuss below are some of the general characteristics of the multi-thread. So the memory overhead is multi-threading is small. It only requires an extra stack, register space, and a space for the thread local data. And CPU, as you call, can overhead is a small scene. It uses application program interface API. And the communication with the process and with the other process are faster. So it gives you faster processors. It can process faster eventually. And the implementing of this is very low and any bug can crash the entire application. So the crash resilience in implementing multi-threading is low. So any bug can crash the entire application. And lastly, the memory usage is monitored via system allocator. It can incur some CPU contention from multiple threads and fragmentation before the memory is reused. And I will discuss the examples of the multi-thread application. So, the application that creates thumbnails of photos from a collection of images. So, the example of are Photoshop, um, some third-party application that you can make photos, edit photos like that, and some are web browsers that displays image or text while retrieving data from the network. So, like Google searching some pictures like that, and word processors like um, Microsoft Word. That is some of the Notepad coding like that. That is the multi-threaded applications that you need multiple threads to function the application. And there are benefits of the multi-threaded programming. So the first of all is the responsiveness. They're incorporating the multi-threading concept in an interactive application allows a program to continue running even if some part of it is blocked or performing a lengthy operation. It responds very quickly and there's resource sharing. So generally, the threads share the memory and resources of the process to which they belong. That is the resource sharing. And the other thing is the economical. Economical is allocating memory or and resources for process creation is inefficient, but the thread creation consumes less time and memory. And the last thing is the scalability. The benefits of it is the multi-threading is being greater when dealing with multiprocessor architecture, where threads can run in parallel on different processing cores. So that's the benefits of it when you have a multi-threaded programming. So Windows is the best good example for supports the multi-threading. And in the Windows OS, threads within the same process can exchange information through their common address space and access shared resources of the process. And that's it. That is the meaning of threads, and that is the about the threads that we discuss. I hope you understand and you learned something today. Thank you very much.